Well, welcome everyone to our August edition of the engineering webinar. This series of monthly engineering webinars is actually produced by the Alabama Broadcast Association Engineering Services and the Engineering Academy. And it is actually underwritten by our good folks at Max Connect Group. If you are not familiar with them, we invite you to check out their website there at maxconnectgroup.com. And they have a full service. They sell equipment, everything from microphones to the antenna, and they have a full service department too. They can do turnkey installations at radio stations. And if you have a problem, they can send they have a crew of engineers and they can send people out and help you with any problems that you might have. So check them out there at maxconnect.com. We always enjoy having them as a sponsor. They also sponsor our regular engineering academy classes that we have throughout the year. We actually have one coming up actually next week. We have the television class is actually coming up. So make sure that if you're interested in that, give us a call and we can get you signed up for that. Our co-host, which is John George, is off somewhere. He said he was going to be on a mountaintop doing a alternative broadcast inspection at a radio station. So he's not going to be with us today. So I wanted to take just a couple of minutes here before we actually switch and bring in our special guest and talk just a little bit about the National EAS test that's coming up. That will be October 4th. And it will actually be fed by iPause over the iPause system at 2:20 Eastern time. That will be 1:20 Central time. So you need to make sure that you get ready for that test. And the way that you do that simply is, first of all, make sure that your EAS device, regardless of what type you have, is running the most current software version, and along with that, the most current FEMA security certificate. That security certificate, people ask me what that is, and I've sort of jokingly said it's sort of a governmental password. It's a way to make sure that things are not getting into the EAS system, any kind of hackers or anything like that. So make sure that your software is up to date and the security certificate is up to date. If you don't know what version you're supposed to be running, then you can contact your equipment vendor and get that information from them. Also, the Form 1 that you have to fill out for the reporting of the reception of the EAS, National EAS test. Form 1 is actually a form that has actually information about your station, where it's located, what city, what state, and what type of equipment you have. Now, that form was actually supposed to be filled out and submitted to the commission February 28th of this year. And some people did and some people didn't. Hopefully you got yours in. If there's any changes, we actually suggest that you go on to the ETRS site on the FCC site and check it to make sure there's nothing changed. And changes may be like you maybe sold the station or some other changes that you need to make. So make sure that you do that. And the commission has said you need to do that. Check that and make sure it's corrected by September 15th, which is only about a month away. So make sure that you do that. And then Form 2 and 3, you remember those from the last time that we did a national test. That was actually Form 2 is filed on the day or the day after the test, which indicates whether or not you got the test and relayed it correctly. And then Form 3 comes a little bit later, where you explain more information about how you received it. Was it the quality good, or did you not get it at all, or was it garbled, or whatever the situation may be. So this is coming up again, October the 4th at 2:20 Eastern time. So make sure that you have your equipment. One way that you can actually tell is have your chief operator, or if you're the chief operator, if not, make sure that you look at the EAS log and make sure that it is actually receiving the required weekly test from FEMA, from IPAWS each Monday. They feed a weekly test on Mondays at 11 a.m. local time, and you should be getting that. And obviously, you're supposed to be checking it once a week anyway and logging it. And if you're getting that, that pretty much indicates that all of your system is set up and working. If it's not, you need to get your engineer on top of it and find out what the problem is. So any questions that anybody has about EAS, you can post it on the chat and we'll see if we can answer it for you. Most of my situation in engineering, like a lot of other engineers, is that we've been in engineering and since back when dirt was invented. I think we've been around a long time. And somebody asked me one time, said, when did you actually get started in broadcasting? I said, well, I think the first remote that I ever did was I set up a Marty at the parting of the Red Sea, and that was probably my my first start. But our special guest today has been in the business probably about as long as I have, and he's seen a lot of changes going on, both in AM and FM. And in addition to be a very accomplished engineer, and he's head of a big organization now, he also is a distinguished pilot. He has his own plane, I believe. And let's welcome into our program today our special guest, Cris Alexander with Crawford Broadcasting. Welcome, and glad to have you with us, Cris.
Thank you, Larry. It's good to be here.
Yeah, I wanted to sort of start off and talk about, like we do a lot of times with guests that have been in the business a long time. How did you actually get into this business? Did you sort of back into it, or actually, how did you get started in broadcasting?
It was really through amateur radio. I was an amateur radio operator as a young teenager, and went through all the license classes there and got those. And it seemed like I always wanted more power. You know, it just wasn't enough. 1,000 watts wasn't enough back in those days, and I kept seeing this. This bunch of towers out kind of on the edge of town. I grew up in Amarillo, Texas. Out there on the east edge of town, I'd see this bunch of towers all in a line, and what is that? You know? And so one day I went by there. I was about 15 years old. And walked in there and looked around. They showed me around, and I filled out an employment application, of all things. And would you know it? They hired me. They hired me to change tapes on the big old Schaefer automation system that they had on the FM. I guess they figured there was no risk there because it was FM and nobody could hear it anyway. And then they had me reading news, just doing rip and read, also on the FM. And then they taught me how to do to run the board on live baseball and even do recreations. And that was my introduction. It was kind of neat because I had a job. I was 15. I was able to get my driver's license. They let you get an occupational license if you could pass the test. So I was able to drive, you know, out there to the east edge of town and do all of that. And they had an engineer there. His name was Don Freestone. He was kind of mysterious. He had his room in the back, his shop, and he was always hunched over a soldering iron with a curl of smoke coming up from it. Always working on something. And I was always kind of looking back there to figure out what was going on. And those glowing tubes back there, there was a 5 kilowatt station, those glowing glass tubes always intrigued me. And anyway, that was my entry. One thing led to another, and you know, here we are. Here we are nearly 50 years later.
You know, a lot of people, I think, when they got started in broadcasting, sort of backed into it that way. I always tell, and I'll tell this real quickly here. I was actually in the speech class in high school, and they decided they wanted to do a 15-minute weekly program on the local AM radio station. It was a daytime, 1 kilowatt daytime station. And they were going to do this 15-minute program every Friday. We want to do it from the library of the high school. And I was sort of selected. I didn't volunteer, but I was sort of selected as the simulated producer, which meant the only thing that I did was I put on a pair of headphones, listened to the announcer at the radio station, and when he told me it was time to start the program, I would point to the people. That was my producing. Well, you could talk back and forth in those days. This was an old phone line remote setup, and you could talk back and forth with the announcer before the show started. And he asked me one day, he said, "Have you ever visited a radio station?" I said, "No." He said, "Well, come on out one day and I'll show you around." I said, "Hey, that'd be cool." So I did. I went out one day and he was showing me around, and I was like you, really enthralled with all the knobs and the switches and the lights and the meters and everything. And I was a ham operator as well at that time. And this old gentleman came in. I didn't know who he was, old gray-haired gentleman. And the announcer that was showing me around introduced me to this gentleman. He said, "This is our engineer on on the high school broadcast." And I thought to myself, engineer? Well, this old gentleman looked at me and he said, "Do you want a job?" And I said, "Well, yeah, I guess that would be pretty neat." He said, "I need somebody to work on Sunday." And so I said, "Yeah, I'll do that." I said, "I don't know anything about what's going on here." He said, "Don't worry, the guy here will teach you, and he'll sit with you a couple of Sundays to get everything okay." The thing I did not know at that time, he meant all day on Sunday. And it was a daytime AM, which meant in the wintertime I could go home at 4:45, but in the summertime it was like 8:30. So it made a long day. So like you, we sort of got backed into it, but one thing led to another, and here we go. The company that you're working with now, talk a little bit about Crawford Broadcasting and what they're involved in, and the disposition, I guess, of AM and FM within the company.
Well, Crawford Broadcasting Company's been around since the really, I guess, in its earliest form since the mid 1940s. But I think we incorporated in 1959, and we've been an entity ever since then. When I came aboard with this company in 1984, we had 6 stations, including Birmingham. We had WDJC in Birmingham. It was one of our big stations, and most of our stations were FM, but we had a couple of AMs, one in Dallas, one in Los Angeles. Since then, we've grown to 30 plus stations. We've been up, we've been down. We bought some, we sold some. We've entered markets and exited markets, but right now we are primarily in, Los Angeles, San Francisco, Denver, Chicago, Detroit, Birmingham, Buffalo, Rochester. I think those are our markets right there. And of course, we have 3 FMs and 2 AMs in the Birmingham market.
Are these individual? Are they programmed individually in each market, or do you have like a network programmings that you feed? How does that work?
Well, there are certain network elements, but each station, each market does its own programming and so forth. So we don't centralize. We're not like EMF or someone else that sends programs to all the stations. They all air the same thing. It's really not only are all the markets different, but all the stations are different. A good number of them are Christian stations, religious programs. Some of them are programs, some of them are music. A lot of them are conservative talk. We have some black gospel stations. So it's really a pretty wide array. And then in Chicago, well, we're not going to talk about Chicago.
Yeah, the reason I brought that up, I was curious if you did have centralized programming that you aired on these stations, what kind of infrastructure you were using. I know that different networks are doing different things now, some on satellite, some on IP. So that was the reason I asked about that.
Well, we have a little of both. We have 2 KU band satellite channels with they're on SES 3, and we're getting ready to move to a different bird, getting bumped off of that one. So we do that, and And then we have, we use a tie-line gateway distribution codecs for the times we need to feed a large group of stations. We can do 30 connections with that one device and do that over IP. So we have a couple of different ways of doing those things when we need to.
How reliable do you see IP like that? Because you're actually on the normal World Wide Web internet. So is it seen to be pretty reliable?
It works perfectly until it doesn't. and and it's amazingly reliable. It really is. We tend to, when we have problems, it tends to be very localized. You know, and a lot of times it can be backhoe fade, or somebody you know, had an accident in the wintertime or whatever, and plowed a pole, took down a node or what have you. Those are the kind of things that we tend to see from time to time. But you know, we don't use these things for STL except for backup as a rule. But you know, for this distribution stuff, the satellite's pretty reliable. But you know, you can get snow in the dish, you get a big snowstorm, or on KU band you get a big rain squall, and that can go down. So you know, I think the satellite's probably a little more reliable than the public internet. It's just more points of possible failure on the internet, but by and large, it works, and you know, you can generally count on it.
Yeah, sure. The KU thing, when you brought up about the rain, I remember a situation. I was actually at a big box store one time, and they had like a kiosk set up, just network did, and they were talking about trying to get you to move over to them, and which operates in the KU band. And the guy was talking about it, and he asked me, did I know anybody in the neighborhood that had this network or anything on KU? And I said, yeah, the lady down the street has it. And said, she really loves it, doesn't it? I said, yeah, pretty well, except when it rains. And the guy, he looked at me and he said, no, we fixed that. I said, and I said, you did what? And my wife was with me. You met my wife out in Las Vegas, I think, one time. She was standing there, and she grabbed a hold of my shirt sleeve. She said, don't go there. I said, no, I got to hear this. I said, you fixed it. What did you do? He said, we put up more satellites. So with that, I had to turn around. So that was it. That was the deal. So yeah, KU works really well. And the SES3 that you're on, we're actually on SES3 here with our redundant EAS satellite system that we have. We have around 45 downlinks that we use to back up the daisy chaining for state and local alerts. And yeah, we're moving over too. I think they're going to SES1, which is just one bird over, but everybody's got a repoint and everything. You mentioned the number of stations that you have. You have more FMs or AMs, or how is it divided up? I just lost your audio.
I'm sorry. I hit the wrong button, and my wife says it's why I can't work at NASA. Anyway, we're in terms of just numbers, we're probably a little more FM than AM, but you know, in terms of market impact, we're probably about evenly divided there. Most of our AMs are big signals.
Yeah, I know that and that's one thing I wanted for you to talk on a little bit today. You've been really involved in AM. You've written a lot of articles for the trades and handbooks and all, and talking about AM. What do you see? You know, sometimes I hear engineers say, you know, FM, you get somebody to hang an antenna on a tower and that's it. You don't have anything else to do. In AM, you actually got something you can do. You can put hands on it and you can work on it. And especially when you get to directional. And I find out in our classes that we have here in Birmingham that a lot of the young people seem to shy away from AM, and they really turn around and run when you talk about directionals. But myself, and I'm sure because of your years in the business, I sort of like AM, and I love directionals. I love to try to bring a directional into compliance. How do you feel about AM and AM directionals?
Well, I'm a lot like old Slim Pickens in Dr. Strangelove.
Right.
I can't remember his character's name, but he learned to quit worrying and love the bomb. Well, I learned to quit worrying and love the AM directional arrays. And you know, they are what they are, and they're really not difficult. They're just different. And so many engineers that are, may have some fear of them. It's probably just unfamiliarity more than anything else. They don't understand perhaps completely how they work, except in the general sense. There's all those those big singing coils. It's kind of spooky at night when you go out to a tuning house and you hear that thing making noise. Those kind of things. And they don't understand them. They're not familiar with them. But there's really no it's not that different from FM. It's just a lower frequency. Here's a good example. We hired a guy. Many of the people on here may know Mike Kernan. Mike was he was Beasley's, and before that, Greater Media's market chief in Detroit for decades. Anyway, Beasley did some downsizing and cut him loose, and I had an opening in Detroit for market chief. Well, Mike, a sharp engineer, he had never messed with an AM before. And boy, talking about out of the frying pan into the fire, he was in the fire in a hurry because we had antenna array issues. We have, of course, we have FMs there, but we had AM antenna issues there and transmitter issues, and I dumped him right into it. And it just didn't take him long at all. And he's very proficient with them now. I mean, really, after the first year, he was completely comfortable with them. So it's just a good example of once you get your feet wet, learn a little about it and quit worrying about it. It's not that difficult.
One of the things that I see in traveling around doing the ABIP inspections in Alabama and talking about it in our engineering classes is that a lot of engineers really don't do the maintenance and care and upkeep that they should. There's a lot more upkeep and maintenance on an AM than there is typically on an FM. And two, somebody told me one time, it seems like the station that actually most often brings in the least amount of revenue costs the most to maintain, and that would be an AM or an AM directional. I know in some of the articles you've written, you've had some pretty good layouts of what an engineer should do to make sure the AM, whether it's DA or non-DA, you might want to talk about that a little bit and talk about I know that the commission has actually sort of done away with the rule where you actually have to go out used to be every month and read the monitor points on a directional. That's sort of gone away. But I encourage engineers that you should still have a meter, a field strength meter, to go out periodically, maybe once a quarter or once every 6 months, and check those, because a couple of times I've run into this on inspection is that the engineer's new, and we go out to read a monitor point, and there's a huge Walmart built at the monitor point, and his comment is, "Wow, when did they build this? I didn't know this was out here." Or even more embarrassing, they don't know where the monitor points is, because the antenna monitor, the AM19 meter there at the transmitter, it's only showing what's happening at the base of the tower. It doesn't show what's happening out in the field. So if you will, talk a little bit about maintenance requirements on AM, and especially in directional.
Well, so many of ours now are not all of them, but nearly all of them are moment method proof now. And so we generally don't do field measurements other than when we actually submit the proof itself. And that's a really good thing. That really changes everything. And that whole doctrine, I was on that committee with the FCC that when we drafted those rules, and I was privileged to participate in them. And one of the doctrines that we used was the clean site doctrine. If it's clean leaving the site, that's really where you lose control of it.
Mhm.
And for so many years, stations that were conventionally proved, it had monitor points. If it wasn't a Walmart, it was a cell tower or a water tower or something else that would disturb the field. And so often there was nothing you could really do about it. You could force the entity. If it was an FCC licensed entity, you could force them to detune it sometimes. And that's one way to go. But so often, a water tower, you're not going to force a city to, put a detuning skirt on a water tower. They may let you do it, but chances are, you're out of luck there. So it's one of the beautiful things about moment method, and I really like to talk it up because it really puts everything back in your control. It puts it back, the things that you can control before the signal leaves your side, everything is good. And then beyond that, it's out of your control. And so don't worry about it. Don't worry about it too much. In terms of maintenance, it seems like, the elements are the things that really eat on AM directional and non-directional antennas. We have tuning houses, or we have weatherproof cabinets, and they can get infested with bugs. They can get dirt in there. They can get water in there. They can get mice and snakes and who knows what else. And you just got to stay on top of that. You've got to look at them often and keep them cleaned out. And if you have a tuning house, one of the things I like to say to do is go out there during the middle of the day, go inside, shut the door, and see if you see any light coming in. And wherever there's light, that's where something can get in, and deal with that. With weatherproof cabinets, it's not quite so easy, but they're generally small enough that you can look and see. You can do just the opposite. A lot of those have a light bulb inside for service. Turn that light bulb on, close the cabinet doors, and look at it at night. If you see light escaping, it's something you need to deal with there. A lot of those weatherproof cabinets have weather stripping around the doors. That stuff does not last forever. It should be replaced every 3 or 4 years. I was at one of the sites with my local chief engineer, Amanda Hopp, here, and I saw she had a great big roll of that weather stripping material, the stuff that Kentronics uses, and it's got to be changed periodically. So those are big deals. Also, keep an eye on your ball gaps on insulated towers. They can get bumped and open too wide, and then they're ineffective. Then the path to ground for lightning or static discharges is right through your equipment. There's no bypass for it. So you need to keep an eye on that. Sometimes those things, particularly in Alabama, it's a good example. Those things get eaten up. You get so much lightning, and you need to replace those. We replaced the ball gaps on 850 out there at Tarrant a few years ago, because they'd gotten so pitted up, that they really weren't all that effective anymore. So those are the big things, and of course, keep the grass, the weeds, and all that stuff cut in the base area. A lot of sites, including at Tarrant, we actually pave over that area. It keeps people from stealing your copper, and it keeps the weeds from coming up. So you just get a company to come in with some blacktop and blacktop over that, and then you don't have to worry about that inside those fenced areas anymore. But short of that, use a frequent use of a herbicide and whatever else to keep it from growing. I do not recommend that you throw rock salt out there. That'll do nasty things to your ground system. In the old days, you just spray some diesel fuel out there, but they come looking for you for doing stuff like that now. So you got to use stuff that probably just doesn't work all that well, and use a lot of it. But you got to keep that growth out of there. It also makes it a much more comfortable place to work. If you're out working in a tuning unit at a tower base, and you're not worried about a snake crawling up your pants leg.
We had a question come up on the chat, and I was going to ask you if you would, for those on the call that are not familiar with the MOM, the question on the chat thing was, does the FCC have a recommended software package that you use for that? And you might, at the same time, you might talk about what EOM actually is.
Okay, yeah, well, MOM is a moment method, and or method of moments, I guess is really what it stands for. And the way it works is you model the antenna system. You calibrate the model. You make a set of base impedance matrix measurements. So you measure each tower with all the others floated, or you measure it with all the others shorted, depending on how tall the towers are. And then you write down that those impedance measurements. Then when you run your model, you calibrate it, you adjust the height of the towers and the width of the towers until the impedance that's shown at the base in your model matches what you've measured in the field. And that gets you to a really good starting point there. And then pretty much everything else you're doing, you're really looking at the moment of all the currents on the tower. But pretty much what you're looking at in terms of what you see on the antenna monitor is stuff that's happening in the base region, and you've calibrated for that. You also calibrate your sample system. All the sample lines have to be the same length within a degree. The antenna impedances, they all have to be not the antenna, but the sample line impedances, they all have to be the same. Your sample transformers, you have to calibrate those to be sure that they are all accurate with each other, with respect to each other. And then when you get through with the model, it produces an output that you can dial in those parameters on the antenna monitor and be confident that it's going to produce the correct pattern in the field. And so after that happens, a couple things happen. You have a new set of license parameters for the site, and you maintain those just like you always would: 5 degrees on ratio, 3 degrees plus or minus 3 degrees on phase, and then you don't have any monitor points to do. And the only time you have to repeat any part of the proof measurement is if something happens to the sample system, or something significant happened to a tower where you had to replace part of it, or do some significant work on it, and then you'd have to repeat the model and repeat those measurements. But the question here was, does the FCC have software packages? One of the things in the rule says you can use anything you want. The problem is there's very little out there that'll do the job. There was a company that everyone was using. I'm trying to think of the name of it. It'll occur to me about 30 minutes after we finish this webinar. But they quit supporting it, and so I wrote my own, and it's commercially available. And the FCC uses the one that I wrote as well. I made it available to them. And by the way, you'd be surprised how hard it is to give something to the FCC. I'm telling you, you have to fill out all kinds of paperwork. They want to be sure that you're not you're not expecting something in return for this. And I understand all of that, but I worked all that out with Ann Gallagher back when we started all this. And so they have my software, which is called ACS model. And the trick with this is you have to be able to come up with a set of base drives that'll produce the pattern. And you need a matrix inversion program to be able to do that. And that was really the hard part, was writing that part of it. If you have that part, you can pretty much use anybody's modeling software. But that was the hard part, and it required some pretty high level math, simultaneous equations. Anyway, I had to relearn a lot of math to be able to write that, but that was the trick of it. So anyway, ACS model is the one that I have, the one that I use, the one the FCC uses.
So, somebody just posted it, something about something about Terra software. Are you familiar with that? Did you see the page, the post there?
That's not the one that I recall. Yeah, I'll think of it here in a few minutes and tell you what it is. It's, some people still have it. It's still out there. And it's just they don't support it anymore. The company's out of business. And so if you have it, you can continue to use it, what that program was, but you can't go buy it anymore.
I saw at one time, Watt Harrison used to be with chief engineer for WSM in Nashville, and he had a software where he was designing arrays, and I don't remember what it was, but it was really cool. He was doing a 4-tower array, and he could sit there and vary all the parameters of each tower, and you could see the pattern just shift around where the nulls were, how deep they were, how far out they were. So is that similar to what you're talking about?
No, that's a different application. I've got one of those too. I call it, you'll think this is really clever. I call it DA design. It took me a long time to come up with that name. But it does the same thing. You can tell it to, you can say, I need 3 towers. I need this tower line, that tower line, and I need nulls of this depth at this place, and that place. And then it will do a preliminary design, and then you can tweak it. You could, just like you're turning knobs on a phaser, you can tweak it and you can see the pattern shrink and twist and move and so forth. And of course you can run all your, you can put all your protections in there, and then those little protection dots will turn black if you clear them, or they turn red if you don't. And it's pretty easy if you're dealing with the daytime, everything's at 0 degrees elevation. It's pretty easy to see that, but a lot of times on your nighttime arrays, you're looking at something that's at a, that's at an angle above the ground, and on the ground it clears it, but in at a higher angle it does not. And so you see these dots turning red that are actually outside your inverse distance line, and you can really see the thing work. So yeah, I do have one of those.
Yeah, I thought that was pretty cool. Directional to the initial design of those things, I've often wondered how, before computers, back in the early days when they were sort of manually designed, people, I guess, went through a whole pack of legal paper and wore out their slide rule, because there's a tremendous, as you say, a tremendous amount of math involved, doing rectangular to polar and polar to rectangular, to all that kind of stuff. And I've often wondered how in the world they did that manually.
Well, an awful lot of it was done by using standard patterns, and I'm not talking about standard pattern that's like in the FCC rules now, where they actually enlarge the pattern with a quadrature factor to give everybody a little more room from their neighbors. I'm talking about, there was a book, and I have it over here, of standard 2-tower patterns, and you can multiply those. You can take this 2-tower pattern and that 2-tower pattern, and you're making a 3-tower dog leg out of those two, and you can see I'm going to have null here, here, and here. And so you could get in the ballpark with that, and then make minor adjustments, and like you say, hundreds of thousands of calculations to figure it out. Those were some really, really smart people back in those days. That's all I've got to say. I got into this really before we had computers to do all of this, and then as we got into the computer age back in the 80s, late 80s, and even into the 90s, everything changed, and it got so much easier. Of course, the big invention that helped more than anything else was the operating impedance bridge. Back in the old days, we used the General Radio 1606 bridge. It was just a static bridge. And if you wanted to know the impedance of something under power, you had to use 2 RF ammeters and a reactance, and then calculate it. And it was very difficult. Now we just insert this operating impedance bridge with the big alligator clips, turn the transmitter on and adjust the dials, and we read it. And that really changed everything. Back in the old days, they really had no way of controlling the match on the transmission line, not really practically. They knew it was going to be a huge mismatch, so they just lived with it. And they had to design for it. They had to have transmission lines that were big enough to handle the standing waves, so you wouldn't have flashovers and so forth. Nowadays, we can design them fairly close, and we can have a really good match on our transmission line, and it gives us a great bandwidth that we could never achieve back in the old days. So we got an awful lot of tools now, and of course now we use network analyzers, and that's changed everything. The late Ron Rackley really pioneered the use of network analyzers in AM arrays. And a lot of us just followed him and bought the power amplifiers and bought the power attenuators and directional couplers and all of those things. So we could tie those things all in, and with a multi-channel analyzer, we could really look at a whole array. That's changed everything again.
I think that may be one of the things that make the newer engineers coming along want to turn around and go the other direction, because there is a lot of stuff you have to do. Now, granted, most of that work is done by consultants designing the array. Once you have an array designed and built to that specification, we always tell people, don't ever touch the knob on the phaser. That once it's set, leave it alone, because you know yourself, you can really get it out of whack in a heartbeat, and at 2 a.m. in the morning you'll never get back where it's supposed to be. So so the maintenance of a directional, other than just making sure everything is working, is pretty much minimal, I suppose. Now you don't have to do a lot of adjusting. And we did have a situation here in Montgomery where we had just a 2-tower array, but I got to noticing we had an inline bridge at the common point, and I noticed when I would go out there, the common point would be off, and I'd readjust the common point back to 50-0, and then the next time I go out there, it would be off again. And this was an open phaser. I don't know if you've ever worked with an open phaser or not. This was for 50 kilowatt, and we had it mounted on the wall, and it was sort of funny. Everybody remembers Angelo Diddy with the FCC out of Atlanta, a little short Italian guy. And he came in to inspect my station years ago, and it was mounted on the wall behind the transmitter. And he just got all over me. He said, "You got to put some sort of protection around that thing." He said, "Somebody could get hurt." I said, "Well, nobody's ever out here except the engineer." He said, "Yeah, but what if you trip and fell over into the coils while it was on?" So we actually ended up putting some sawhorses with morning tape on the sawhorses around it, so you couldn't get close to it. But what I found while it was changing, the adjustment for the common point, where you ended up adjusting, the slider on the core was right up at the top, and there was the coupling in the tuning was not tight, and so all the jarring around of air and all this kind of stuff, it would over time would slide down, and it would actually go halfway down to the bottom, and I'd move it back up, and the next time I went out, it would be off, and I'd find it be down again. We finally found there was a little Allen screw that tightens a coupler on the coil, and we did that, and that stopped it. But the thing, and I'm sure you share this with all your engineers, once it's adjusted, first of all, write down all the counter readings on the phaser knobs, and then leave it alone. If something happens, 99% of the time, it's not because it's out of tune.
Yeah, that's right. And I do tell them that, and I've told people that in various other venues for many years, is that don't try to fix a problem with phaser controls. Figure out what caused the problem. It's not, unless somebody maliciously or in ignorance came in and cranked the phaser controls. Cranking them is at best going to kick the can down the road. At worst, you're introducing a whole new variable into the equation that you're going to have to solve later. So figure out what the problem is instead of messing with the phaser controls. And you shouldn't, it's a raised drift around, wet to dry, cold to hot. You see those kind of things, and so you may need to touch it up a little bit. But when you come out there and you got a tower that's 20% out or 15 degrees off, look around and see what's causing that before you go messing with a phaser control at all. You shouldn't really have to turn a control more than half a turn under normal circumstances. And if you do, there's probably something wrong.
Well, one of the things we always use in the class, we tell people when you visit your transmitter site and do it regularly, the good engineering practice, I think, is always visit your site once a week. And most people say, whoa, I don't have time to go out there every week. Well, you should go out there as often as you can, because things will change, And I said, you need to learn the look, the sound, and the smell of your site. Something burning or something. So learning the look of it, go down and look at the ATU, like you were saying, open the door and see if there's any rodents have gotten in there. Jeff Weldon, and you may have heard this story, Jeff Weldon, when I'll tells this funny story that he got a call out to help a station that had a 50 kilowatt 3-tower array, and they couldn't keep the transmitter on. It kept tripping off. And he checks everything and the transmitter's fine and everything looks okay in the phaser. He said, well, let's go down and look at the ATUs at the tower. And he opens up the first one and there was nothing broke. Sometimes the insulators, will break on mounting insulators, but he didn't find anything wrong. Went down to the second tower, opened it up. It was just as clean as could be. Went down to the third tower to open it up. And there was a nice size rattlesnake in the cabinet wrapped around the coils. He shut the door. He said, we can solve this. He goes back up to the transmitter and hits the plate on, cha-choon, plate on, cha-choon, plate on, cha-choon. And he tells the engineer, now go out there and clean up that mess. That was one way to get the snake out of there, just burn him up. So the things will get in there and eat up stuff. Let's change gears a little bit here. When you are hiring new engineers for a facility, what are the traits that you look at in a person that you would like that person to have that's going to be an engineer at one of your stations?
Well, that's really that's a moving target, Larry. It used to be I could answer that question very simply. Now it's a whole lot harder. For one thing, the qualifications that I would put on them, unless it's a veteran, like I was telling you about Mike Kernan a little earlier, unless it's an industry veteran that just becomes available, it's hard to find anyone that has those qualifications. So nowadays we tend to look for IT trained people and then hire them in and then train them up in the RF side of things and the audio side of things. And of course, so much of the audio now is IT. All of our facilities are all AOIP. There's not any analog audio anywhere anymore in our facilities. We've pretty much done away with it, and it's all AOIP. And so those people, they can be pretty much at home from day one in that environment. So it's the RF side where you've got to train them up. So that's kind of where we are right now, Larry. It's hard to find. It's just really nearly impossible to find someone that is a trained, competent RF engineer that you can just drop in and say it's all yours.
That's exactly right. Back in the old days, when everything was analog, and then when IT started coming into the business, major market stations were able to have two people, an RF, a broadcast guy, and an IT guy, and sometimes that worked and sometimes it didn't. There was a lot of sometimes disagreements, or some stuff, but we always say that the broadcast guy felt like he knew what that box and that rack did, He knew how to install it and program it and make it work. He just didn't quite understand how to make that box talk to another box. The IT guy on the other side of the hall, he didn't know what the box was for and what it did, but he knew how to make the two boxes talk to each other. Well, as we've gone along now, as you say, it's sort of merged together. The IT and the broadcast has sort of merged themselves together, where a broadcast engineer has to have a basic knowledge of IT to understand how you make things talk to each other. At the same time, how to keep the equipment working. I think you're right. It's difficult to find. I know in our classes that we have, they're 5-day classes, and they're designed for people that are just beginning into the broadcast field. And we know, and we knew going in when we started this academy back some 10 or so years, 11 years ago, I can't make engineers in 5 days, chief engineers in 5 days. That's a pipe dream. But what we try to do in the classes is give enough basic information that they won't feel like a deer in the headlight look when they walk into a station and start working maybe under a chief or somebody like that. They'll have a basic understanding. And we actually cover, as some on the call know that has been to our class, we actually start on Monday with basic electronics. We talk about the basics of electronics, which I think, and I'm sure you would agree, that to be proficient in this business, you sort of have to have a basic understanding of how does it work? How does electricity work and makes it work, like capacitors and inductors, and especially when you get into AM and AM directional rays. And then we cover audio on Tuesdays, both analog and digital. And then on Wednesdays is when we do RF and go through transmitters. We don't, but like I said, we can't go that deep into in 5 days. And even if we could, you got to have experience. That's what you were talking about. You got to have somebody that's been in the business and understand it. One of the pitfalls of using IT, and you really have to, and I'm sure you are aware of this as well, you really have to groom them along, because an IT guy could blow himself up at the transmitter.
That's right.
if he didn't know what was going on. So you sort of have to do those as well. Are you finding that works well to bring IT people in and teach them RF rather than hiring RF people and teaching them IT?
Well, I guess the answer would be yes, because I can't find any RF people. Pretty much. They're in Birmingham. We hired 20 plus years ago Todd Dixon. He was a young man with an interest in radio and so forth, and Stephen Poole brought him up and taught him all of this stuff. And Todd, he learned it all on his way up. I'm talking the RF and the IT. And so he's really one of my go-to people in the whole company now for IT things, but he's an RF engineer as well. He's very good, and we've just brought him up. And we look for people like that when we can find them, and occasionally we do. Here in Denver, recently, Amanda Hopp is our chief engineer, and yeah, she's my daughter. She's 37 years old and has been with our company for 20 plus years, and has been chief engineer here for a long time. And she found a young IT guy that has an interest in radio and wants to learn about it. So we've hired him part-time, and she's teaching him those things. So sometimes you can find people like that. It's easier to find IT people that you can train in RF than the other way around.
Mhm.
I don't know what would be easier though. It's probably easier to teach IT people about the RF, but you're absolutely right about people. They can certainly get hurt. And I would say that we've probably got a bunch of veterans watching this right now, and even for our veterans, they need to pay attention to those things. Stephen Poole called me Saturday night. He was at the Coleman site, the 101 site up there. Power had gone out, didn't have any power in the building. He was trying to sort it out. He had a funny smell in there. Coleman Electric said the power was on, and we're talking 480 here, 3-phase, and he's trying to figure it out. And I reminded him, I probably didn't need to, but I told him, I said, Stephen, I don't want you poking around in that stuff if you're up there by yourself.
Mhm.
Don't do it. Wait until somebody else gets there and then poke around, because it doesn't take much of a mistake to get hurt. And people like Stephen have been in the business for 50 years. They know this stuff. But someone new, an IT guy, the highest voltage he ever sees is plus or minus 12 volts inside a PC probably, and it's not that much danger. And so we've certainly got to make them aware of those things and put policies and practices into place to protect those people, and to make it automatic that they don't do things that can get them hurt.
Yeah, it's like the shorting stick that we have in the back of transmitters, and obviously it's got another name called the Jesus stick, because if you don't use it, you could probably see him sooner than you had planned to. So that thing is very important to make sure that you use those things and all. One thing is we're about to run out of time here, but I know you and I talked prior to setting up this program. You have a station in Birmingham that has applied with the commission to go all digital on AM. And I know you said you were not quite up to date on all the ramifications of all digital, but you might talk a little bit about it and what you know about it, or what was the driving force of doing that?
Well, yeah, we WYDE AM 1260 there in Birmingham. We're going to, it's 1260, 1250. We're going to take it all digital on September 1st. We've already done all the public notice and everything that the rules require. And so September 1st is our day. Why are we doing it? Well, it's the perfect station to do it, because it is 100% program duplicated with both a full power FM and a translator right in downtown Birmingham. And so there's no risk for us to do that. And we want to see how it works. Everything I know about all digital AM, I've learned from webinars on SPE webinars and NAB stuff and so forth. I've never dealt with it firsthand. Even this, I'm going to be dealing with it secondhand. Todd Dixon's the one who's going to be doing it all. And I had him run some tests during the experimental period. I want to see if it worked, and make sure our antenna would pass. It's a non-directional, it's a skirted tower, 200-foot tower, right on the east edge of downtown Birmingham there. Anybody that's been in that area and has taken the Red Mountain Expressway off of I-20 there, you've driven right past the tower and seen it there. And so he tried that, and it was so simple. He had to make a change in the exporter, and then he had to change a mode in the transmitter itself. By the way, it's a Nautel NX5, about 3-year-old transmitter. So, and it's already running in the digital hybrid mode and has been for many years. So he did that, and it came right up, and it worked. The antenna didn't have any problem with it. And then he did a drive test around town and found it sounded great. So I guess we'll see, Larry. It's a brave new world. I would say we're going where no man has gone before, but it's more like we're going where few men have gone before.
That's exactly right. I think the critical thing, from what I understand, is the bandwidth of the tower itself, or the antenna system itself has to be set up correctly.
Yeah, that's right. And this one, again, this is a skirted non-directional tower. The only thing, I think all we have is a series capacitor. There's not really any tuning components to speak of there. The impedance slope is very, very shallow on this. So it seemed to perform just fine when we did our initial tests in it. So anyway, anybody, any of these participants here in the Birmingham area or outside of Birmingham, once we do it, I'd love to hear any reports back on what you notice on this thing.
Yeah, I look forward to that. Well, Cris, I appreciate you being with us. And this has been most informative, a lot of good information, and that's why I wanted you on the call, because I knew you've been in it long enough that you've seen a lot of stuff and done right. You've seen a lot of stuff done wrong. So we really appreciate you being with us today.
Thank you, Larry.
I had another question that came up on the chat room about EAS. Somebody asked about the monitoring assignments and making sure that you've got what you're supposed to have. Yes, you're supposed to have 2 local sources that you monitor. This is required by the commission. This is for the daisy chain. Plus, you have to monitor IPOS as well. So the minimum thing that you have to do is have 2 local sources plus the input from the IPOS network. So that's how that works. I hope that answered the questions that somebody had there. So with that in mind, we'll if anybody has any other questions, they can post it or share, send us an email, and we'll address that and help you out with it. Again, thank everybody for being with us today. Our next seminar will be on September the 19th, which is the 3rd Tuesday in September. And we'll sign off now and look forward to seeing you in September. Thanks, everybody.